Okay, we are recording, and
Okay.
okay, are you guys ready to start?
I'm just opening mine up now.
Okay.
Okay. A lot of questions today.
Yeah.
There are a lot.
And I hadn't been able to go over all of the questions before the meeting today. And so I understand a lot of it, so I'm hoping to be able to do it sort of as I go. But just so if I'm going a little slow, that's
okay.
why. So
That's okay. I just slightly worked ahead, but some of them I was like, oh no.
yeah.
I don't remember. So I can start with question 2 if you guys are ready.
Okay.
Alrighty.
Okay. Given a 90% confidence interval of 105 for mean heart rate, which of the following is the best interpretation of this confidence interval? And I put, we are 90% confident that the true mean heart rate is between 45 and 105.
Me too.
Agreed.
Agreed.
Okay.
Okay, so for question 3, I can do that one. So researchers at the state of Mississippi wanted to determine whether the reaction time in seconds to go or no-go stimulus of males differed from that of females. The researchers randomly selected 20 females and 15 males to participate. The go and no-go stimulus required the student to respond to a particular stimulus and not to respond to other stimuli. So the question, the researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they created QQ plots of both random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? So I had done it. I said yes because the distribution of the mean of each sample is normal since the data have been determined to be normal.
Agreed.
Agreed.
Okay.
Okay.
Okay, question 4. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? So I would think it's using the independent samples.
That's what I had is the third one.
Yeah, that's what I have as well. So
Yes.
Okay, cool.
I was interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% interval or confidence interval for the mean savings account balance of bank customers is found to be $3,402.08 and $4,142.75. Which of the following would produce a confidence interval with smaller margin of error than this 95% confidence interval? And put obtain the balances of 90 bank customers rather than 30.
that is what I had put.
Yes.
Sounds good.
So, and the reason why I put that is because I didn't put any real data in, but I just changed confidence intervals from like 95 to 99, and it actually made it go bigger. So,
yeah, because if you're more confident, your range will actually be bigger because if you have to have a bigger range for it. So.
Yep. So I played around with it and then decided that a larger sample would be.
Yes.
So, okay.
Okay.
Ooh. Ronaldo, do you want to do this one?
Okay. A factory makes properly drives shafts for ships. A quality assurance engineer at the factory needs to estimate the true mean length of the shafts. Okay. She randomly selects 4 drive shafts made at the factory, measures their length, and finds their sample means to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate 95% confidence interval for the true mean length of the shafts. Input your answers for the margin of error, lower bound, and upper bound. Question number 6, determine the margin of error for this 95% confidence interval. Okay, let me, I didn't answer yet. Just a minute.
Jeff, is the Wi-Fi working now or no? I just want to try if I can turn my Wi-Fi.
Is the rest of it ready? Oh. Sorry, guys.
It's okay.
You can.
So I just have a question on this one. I wasn't quite sure, but aren't we doing the margin of error sigma known?
Yes.
Okay. But see, I have that one as it's a z-test, and isn't a z-test for a population when you know the population standard deviation? And the t-test is for the sample standard?
Well, so yes, so this one, I guess, because it seems like, so as I read it, so it says she randomly selects 4 drive shafts made at the factory, measures their lengths, finds the sample mean to be 1,000 millimeters. And referring to those lengths that she found, it says the lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. And so this would be that would be the standard deviation of the sample, not the population, right?
That's what I thought. And so, so for if you have a sample, then that should be a t-test, I thought.
Yes.
When I did it in the t-test, yeah.
You did it in the t-test? Oh, because my t-test is, oh. Well, how did I get that? Because I did it in the z-test. Because, oh. I don't know why I had that. I mean, because obviously it's going to work either way. I was reading my t-test wrong, and I was like, but that can't be right either. Okay, yep, don't. It's supposed to be a t-test.
So when, I guess for the t-test, like using the Excel sheet, the quantitative inference procedures one, you do the 1 sample t-test for means, right? So the very first one.
Okay, say that all again. I'm sorry, I was.
No, you're good. So what I did was I pulled up on our Excel spreadsheet the inference procedure, just the very first of the tabs, the 1 sample t-test for mean, and then under n I did 4, mean I did 1,000, standard deviation of 2, and then base it off of that. Is that accurate?
Okay, on the one sample t-test, you did the mean as in, say,
Like where it says variable
That's-
1, rather than having it based off of the data, I just inputted 4, the mean is 1,000, which is what she put, and then a standard deviation of 2 in order to have it show the confidence interval, is what I had done. I don't know if that's accurate, though.
Yes.
my,
Well, there isn't
Mine
really any data to input, right?
Yeah, so we literally only have,
The mean, standard
The
deviation, and
okay. Just wanted to make sure I'm
So-
not going crazy.
and you're doing this on the quantitative inference procedures spreadsheet?
Mhm.
Yep.
So up there in the summary statistics, you put a mean as 1,000 and standard deviation is 2 and your number is 4?
I did it in variable
Oh my
1,
god.
but either way you do it, I think it's
Yes, in the variable one, no? What data
So
did you put?
4. Hang on.
And so using that for the margin of error, then I got 3.182. Could be wrong.
So I obviously am doing this wrong because I don't get that.
What number did you use in the end?
What is the number for 95%? It's
1.96, I think.
what is it?
1.96.
1. Okay, I thought it was 2 for some reason.
So I
1.96.
put
Yes,
in for
I
the
agree.
T sample.
One sample t-test, I use it, no? I put mean 1,000, standard deviation 2, and n equals 4. So the interval of confidence, 3.182.
That's what I have, but
Okay, so can you share your screen and show us how you did that, Jeffrey?
yeah, let's see if it works because I have
I'm
2
really
monitors.
confused.
We'll find out how I can do this. Um, Screen share. Okay. Sharing. All right.
Okay.
So what I did is just over here, the variable 1. I
Mhm.
inputted the n for 4, the mean for 1,000, the standard deviation for 2. And then I have down here the margin of error, and I have it just do the upper bound minus the lower bound divided by 2.
Oh, okay. Let me try it that way. I was okay. So the mean was 1, 2, 3. Standard deviation is 2. Oh. Oh my goodness. I'm struggling with this. Let's see. So you had the mean, the n is 4, the mean as 1,000.
Yep.
And the standard deviation is 2, right?
Correct.
And you have this big one minus this little one.
And then divide that by 2.
Oh, that's right. I'm forgetting divided by 2. Divided by 2. I get 3.182, right?
Correct.
Okay, so I totally did it wrong the first time because I was using the margin of error sigma unknown as T, or as the 196, because it's a 95% confidence rate, times the sample standard deviation divided by the square root of 4.
Okay. Yeah, so I think
So
basically, as far as I understand, we use what we're given in the Excel sheet of just, they already have it set up to determine a confidence interval based off of the mean, the sample size, and the standard deviation. So we just have to input those 3 and it'll generate that for us.
okay, I'll believe you. All right, that's good to know.
Okay. So 3.182, got that. The lower bound then would be respectively 996.818, rounded to 3 decimal places. The upper bound is 1003.182.
Yes, great.
Perfect.
Okay.
Okay, question 9. To assess the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weighings is computed. Suppose the scale readings are normally distributed with unknown mean and standard deviation of 0.01. How large should n be so that a 95% confidence interval for the mean has a margin of error of plus or minus 0.0001? Okay, so are we supposed to use the applet for this?
Well, in this, so what we're trying to do is determine, this is the main thing, is we want to know how many times we're going to have to weigh this 1 gram to get a margin of error of 0.0001. And so would this be when we would use like that sample size formula that we were given?
That's what let me pull up. That's what I did. I did the n equals the population standard deviation divided by the margin of error to the 2nd power, right?
Z times sigma over m squared. Is that the formula you're talking about?
Yep.
N equals population standard deviation divided by?
The standard deviation was 0.01 divided by the margin of error, which was 0.0001.
And then for Z, we just use the number for the 95% confidence interval? Or no?
Yes.
Which is 1.296?
1.96.
Oh, just 1.96.
So, okay, so I just want to make sure as I'm putting this into the right. So we get the 1.96 based off of the confidence interval, multiply that by our, is that alpha? Is that what it is, like the level of significance, or what is that?
So it's multiplied by the standard deviation.
Okay, there we go. Standard deviation.
Divided by the margin of error.
And then squared, the whole thing.
Oh, I think I did. So did you guys get 38,416?
Yes.
Okay.
Oh, good.
What is the answer? 30,000.
38,416.
Let me.
Yep, that's what I have.
Oh, good.
416. Correct?
Okay. Mm-hmm.
Okay.
Okay, the mean area of mu of the several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicions. The appropriate null and alternative hypothesis is HO and HA for mu are, I put number 4.
Yeah, number 4, the list.
HO equals mu equals 1250 and hypothesis alternative equals mu less than 1250.
Yes.
Yep.
I would agree.
Okay.
Okay. On number 11, so statistical test of hypotheses, we say reject the null hypothesis. The level of significance of alpha if the p-value is less than alpha, correct?
Agree.
Second option. Yes.
I guess it's me. A group of statistics students wants to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of size 15 from each of 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal. Can they use ANOVA hypothesis test to answer their question?
Yes.
If they're all equal and it's bell-shaped with no outliers, I would say yes. There's 2 yeses. Oh, yeah. Yes, it is enough that the data.
Yes,
That one?
the third option for me.
Correct.
Okay.
A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. The null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. In an earlier trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with a particular type of cancer. The researcher has committed a type 1 error.
Yes, because they reject the news. Yes. Okay. Question 14 now.
Yep.
The level of significance alpha is made very small, thereby making the probability of committing a type 1 error very small. What happens to the probability of committing a type 2 error? I think the first, no?
Mm-hmm.
I agree.
I would agree.
Okay.
The nicotine content in cigarettes of a certain brand is normally distributed with mean in milligrams, mu, and a known standard deviation of 0.17. The brand advertises the mean nicotine content of its cigarettes is 1.5, but measurements on a random sample of 100 cigarettes of this brand gave a sample mean of X bar 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis. Okay. Anybody can jump in on this one because I didn't do this one.
Neither did I.
I'm not quite sure how.
Well, it says level of significance is 0.05. So
Wait, I bet you can do.
Reject the new hypothesis.
So that's, I mean, if you put it in like we did that last time into the variable one.
Uh-huh.
Oh, wait.
Yes, I used the one sample.
We don't, oh, we have 100. Wait. So that gives us a p-value of like a negative 0.0000000, right?
mhm. Mhm.
So yes, Danny, do you want to share your screen just so I can see how you put it in? I just want to see if I'm putting mine in the same.
You bet. Let me. Okay, so I put it in as N100, mean is 1.53, standard deviation is 1.7 or 0.17, and then I get this p-value.
You also want to make sure you set what the null hypothesis is when we're dealing with the p-value.
Yes.
What was the null hypothesis?
1.5.
Oh.
Yes.
Okay, that's the same number I have.
Yes, I found
Okay.
0.040, the p-value.
I have 0.080.
Yeah, that's what I have as well. Oh,
So we would fail to reject the null on this.
correct. That's what I have as well, so I would agree.
So
Okay,
what sample did you use? Because I found a different result in the p-value.
So did you set it up? Let me share my screen again.
Okay.
Did you set it up like this where you have the null hypothesis is 1.5?
Yes.
And then you have, your number
so
at 100?
You use a type of test not equal to, but you need to use greater than.
Are we supposed to?
You use the type of test not equal to, but you need to use greater than.
Oh,
Is it supposed to be less than?
Greater than, no?
For the alternative, it says mu is greater than 1.5.
Yes,
Oh,
yes.
so then it is 040.
Yes. Now that's correct. No, so we
Got it. So we
reject-
reject the null.
So we
Yes.
reject the null. Good catch, Ronaldo.
yes, yes.
So we reject.
Yes, we reject.
Yep, the last one, right?
Yeah.
That's correct.
Okay. Good catch.
Okay.
Okay, so 16. You would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? And so that would be that'd be just a 2-sample t-test with a independent samples t-test, right?
Correct.
It's independent.
An educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling? I think that's dependent, because if you select a brother, so as to compare as academic, you must include a sister, correct?
Correct.
So the last one.
So what? The second?
The
The
last
last
one on
one.
that one.
Let me see. Yes, agreed. Okay.
Okay. The soil scientists collected random soil samples from a field and measured the dissolved organic carbon level of each sample. The measurements are recorded in dissolved organic carbon. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. One of the 4 types of confidence intervals listed below, which one is appropriate for this situation? And I put confidence interval for mu when sigma is unknown, but I'm not sure.
Well, so I mean, immediately we can eliminate the second and the fourth one because we know it's especially if you open up the file, there's only one set of data, so we know it's only a 1-sample test.
Yep.
And based off it, so the sigma is the isn't that the mean of the population, right? Or is that the mean of? So, I mean, we don't have the mean of the population, right?
So the sigma, isn't that the standard deviation of the population or the sample?
Is it of the sample or is it?
I thought the mu was the mean of the sample. And, oh, wait, no, mu x bar and mu. Right? Because the x bar is the mean for a sample where mu is the mean of the population, right?
I think the first, no?
I don't know, that's what we're...
Yeah, because we are using the t-test, you know, the t-test is used when we don't know. No,
That's true, yeah.
Okay, because if we know the mi and the sigma, we cannot use the t-test, you know, we use the z-test.
Ah, that's true.
Yes.
Oh,
So the first one?
Yes, the first one.
that's what I put. But isn't, okay, so let's go back to that. What is the sigma then?
Let's do this. So it's sigma is representative of the standard deviation.
Yes, deviation.
I'm just trying to see if it is based off of the
sample?
population or the sample.
Or the population.
So what it says, so it's a measure that is used to quantify the amount of variation or dispersion of a set of data sets.
Okay, so it must be of the population then. Okay.
Yeah. So I would. That's what I thought. I just wanted to make sure.
Okay. Nope. You're right.
Okay.
Okay.
And then which of the following is the 95% confidence interval for this analysis? Input your answers for the margin of error, lower bound, and upper bound. Determine the margin of error for this 95% confidence interval based off of inputting the data and letting the Excel sheet do what it does. I got 2.025.
Yes.
That's what I got.
Okay.
0.25.
Hang on.
Lower bound 11.
Mm-mm.
Upper bound 15.217.
Yeah. Are you getting that, Danny, or?
No, because I got, okay, so what did you get for the margin of error?
2.025.
Yes.
Did you clear out all the other information?
That's what I just did, and I'm thinking I didn't get it because, oh, I forgot. So I get 2.0,
Mm-hmm.
2.025. Okay, yep, that's what I got.
Okay.
And then lower, I got 11.168.
Yep.
Upper, I got 15.217.
Yep.
That's what I have.
Perfect. Yay. Okay, we want to know if there is a difference in mean listing prices between Hummers for sale in Los Angeles, Group 1, and Hummers for sale in New York, Group 2. Created 95% confidence interval for the true mean difference of mean listing prices between the two cities. Of the 4 types of confidence intervals listed below, which one is appropriate for this situation? And I put confidence intervals for the mean of differences using dependent samples.
Yes.
Okay.
Oh, wait.
Because there's 2 sets of data.
That's what I thought, and we're looking at
But
the
it would be independent because
But it,
the specific Hummer you choose in Los Angeles is not going to determine the Hummer you choose in New York.
exactly. That's where I'm kind of hung up. I think I'm getting hung up on the differences.
So
So we
it's-
don't, shoot.
So it's a difference, like obviously, so whether it's independent or dependent sampling, so whether we do the paired sample t-test or just the 2 sample t-test, it's still us trying to, we're taking the difference and then doing the mean of, we're basing it off of the difference in the means. Just one
Right.
is like a paired, I'm trying to, yeah, so I think it would be using independent samples because
I think so
yes,
too,
we're
'cause
choosing Hummers, but they're different Hummers, and which one you choose doesn't correlate necessarily.
I agree. I think we're looking for the difference of means, not the mean difference.
Yes.
Okay. Yep. I choose 3 then.
So the independent samples.
Yep.
Agreed.
Copying over my data.
Oh man, I had this all copied over at one time and I had to close my copy.
There's a long one. Oh, there it is.
It is a long one.
And it's not side by side and pretty, so you have to sort of
It's so annoying, right?
Yeah, it's like, yeah, not a huge
Great.
deal, but yeah, me too.
I can at least make it nice. Okay.
Price Los Angeles.
Okay.
And
So
this is
then
a
we
2 sample t-test.
Yes, I
Yes.
think.
Okay.
yeah. 'Cause I don't think. Let's see. Let me just look really fast. They want to know the difference in mean. Yep. So it doesn't say higher or lower. So input the lower bound. I have negative 423.238.
Just a minute, I'm putting yet on the.
What do you have?
Negative 423.238.
Hmm.
The lower bound, sorry. What is your answer? Minus.
Negative 423.238.
Yes, that's what I got.
That's
Did
what
you
I
guys-
have.
Did you guys put the price and the mileage columns in?
No, I put the price. So the price of LA went in variable 1 and the price of New York went in variable 2.
Yes.
Oh, wait. I only have LA.
No, keep scrolling down. You should have New York too. They're long.
Yeah, so New
Oh,
York's
I see.
under
I see.
LA. Yeah,
Yeah, I did that wrong. Hold up. Sorry.
that would
That's okay.
explain the confusion.
Yes. I didn't even notice that it stopped. Just a second. Sorry, guys.
That's
No,
okay.
you're good.
Okay, what did you say it was again for the lower bound?
Lower bound was negative 423.238.
What the heck? I have negative 874.
Did you clear it out? Because one is longer than the other.
Yeah.
Yes.
Yeah, I undid. I think so. Does yours go down to 175 for the first column?
Mine only goes. My first one only goes to 112.
Oh.
Yes.
Hold on. Okay, we both cleared out. Let me try this again. Sorry, guys.
No, that's
it's
okay.
fine.
Yeah, no problem.
Okay. So I thought I cleared it out. Apparently not. Okay, negative 423.238.
Yeah,
Yes.
Okay. Thanks for your patience. Sorry.
totally fine.
And then the upper bound, I have 5417.336.
Yes.
Yep.
Perfect.
Okay. Many studies have suggested that there is a link between exercise and healthy bones. Exercise stresses the bones, and this causes them to get stronger. One study examined the effects of jumping on the bone density of a growing rat. There were 3 groups. Rats were selected at random for the 3 groups, a control with no jumping and low jump groups. The low jump height was 30 centimeters and the high jump group 60 centimeters. After 8 weeks of 10 jumps per day, 5 days per week, the bone density of the rats expressed in milligrams and centimeters 3 cubed was measured. The data was recorded.
Okay, so on this
Researchers would
one,
like to.
real quick,
Go
sorry.
ahead.
So just as I was inputting it in the, because this is, we do the like ANOVA test is where we input this. So I
Uh-huh.
did the control as variable 1, and then low jump is 2, high jump is 3, just so we all have it the same as we look at things. Anyways, sorry, continue.
Okay. No,
Okay.
that's perfect. Okay, the researchers would like to determine if the mean levels of bone density are different between the 3 different groups of rats, nasty, listed above. Use and confidence interval sigma level of 0.05. What is the correct hypothesis test for this situation? ANOVA, good job. Okay, let me,
ANOVA?
ANOVA.
Yes. So control, group 1, correct?
Yes, control is group 1.
Yeah.
Low jump, group 2.
Yep. And then high jump is group 3.
Calculate the test statistics. I got 7.978.
That is what I have.
What did you say? 79.8?
7.978. Did you clear out the other data on variable 4, 5, and 6?
Oh my
So
God, I'm an idiot.
26.
No.
The test statistic is 7.978.
Correct.
Correct.
Yes, 7.978.
It's okay. We're all in this together.
Oh my heck. In my defense, I've been doing accounting for like the past 2 hours, so my brain is.
I'm sorry.
You know what? That's enough. You are forgiven. That phrase anyway. I hate it.
Yeah.
Okay, so give the p-value. I have a p-value of 0.002.
Same.
Yes.
Same. Okay, so which of the following best expresses the conclusion of this test? Uses the level of significance. Alpha is 0.05. So I would say that there is sufficient. So there is sufficient evidence to conclude that the mean bone density of at least one of the groups is different from the mean bone density of at least one of the other groups. So the fourth one, is that right?
It's a fourth?
Yes, I agree.
Oh,
I
yeah,
guess
it is
there's
a fourth.
5. Yes. I was like, wait.
I know,
Yes.
same. I was like, no, it's a third.
I did too. Awesome. Okay. I'm going to clear out the data on this ANOVA really fast.
Pressures of supply and demand act directly on the prices of an airline ticket. As the seats available on the plane begin to fill, airlines raise the price. If seats on a flight do not sell well, an airline may discount the tickets or even cancel the flight. A study was undertaken to determine if there is a difference in the mean cost of an airline ticket purchased 90 days in advance of a scheduled flight compared with a ticket purchased only 14 days in advance. Data were collected on the cost of a one-way ticket from London's Heathrow Airport to a variety of destinations in Europe. The lowest published ticket prices of one-way flights from Heathrow to various destinations in Europe was recorded for each scheduled flight 90 days in advance, and then again 14 days in advance. The data is recorded in that document. Perform a hypothesis test to determine if there is a difference in the mean cost of the nonstop flights when tickets are purchased 14 days in advance compared to 90 days in advance. Use a level of significance of alpha equals 0.10. For the next 4 questions, do 14 days to 90 days for the analysis. Question 29, what is the correct hypothesis test for this? Let me look at the data real quick. So it's just 2. Independent samples test?
I would say a dependent.
Yeah, because it's the same flights, just at different points of time before the flight.
Okay.
So did you put the first one
No,
The last one.
or the last one? Dependent.
Yep.
Yes.
30, so calculate the test statistic. So the t that I have is 1.685.
Did you put 14 days and then 90 days, or 90 days and then 14 days?
I copied it directly how it was in the file.
So 14 first.
Yeah, you use the parrot sample t-test.
Okay, so I got a test statistic of 1.685. Is that right?
That's what I have.
That's what I have.
1.685.
Yep.
Correct?
Yep.
Okay.
The p-value is 0.0957.
Yep.
Or
Point
0.095.
6.
That's in 0.096. That's what I meant.
Yes.
Yep.
0.096, correct?
Yeah.
Okay.
And there is insufficient evidence to conclude that there is insufficient evidence to conclude that there is a difference in the mean cost of tickets purchased 14 days in advance compared to 90 days in advance.
Wouldn't it be there is sufficient evidence because we're using an alpha of 0.1 and our p-value is 0.09, and so there would be sufficient evidence. So the second
There
one
is sufficient evidence. Yep.
Okay.
I would too. Nope, I had it backwards in my head. Yep.
Okay. Just want to make sure I wasn't going
number
crazy.
2.
Yep.
Sounds good.
Nope, you weren't. As soon as you said it, I was like, ugh. When it's low, reject the null.
Okay.
Good.
The second.
Okay.
Yeah, the second one.
Yes.
Yeah.
Second one.
Yes. I'm saving all my responses. I'm going to submit.
Submit.
Oh my gosh.
Did it 17 times.
Seriously,
Hey, 93%.
give your blood type. Serious?
Mm-hmm. You only got 2 wrong.
What did we miss?
Yes, 93. Two errors.
So
Which ones did we miss?
7 and 8. Well, so we missed 6, 7, and 8.
Yeah, 7, 8. Yes.
Oh, that one problem.
Yeah, I was not very confident about that, not gonna lie.
Oh shoot, I just closed mine out because I had different answers the first time.
You probably did it right.
Yes.
Used the okay, so I had a lower of 9.98 or excuse me 998.04 because I did the formula, the confidence interval sigma known, and then I had a margin of error of 1.960.
1.960. Okay.
I think so.
That sounds probably like you did it the right way, would be my guess.
I don't know. I mean, you guys don't have to redo your exam. I think I'm going to just use those numbers to see if that's where I went wrong. So.
Yeah.
So, but that's just what I'm going to do. So.
Okay.
You guys are awesome. Good luck on your exam.
Yeah,
Okay.
good luck.
Good luck, guys.
Thanks. Bye, guys.
All right.
Bye.
Bye.
Okay, thank you. Okay.